Greetings. So I've got a part here that has two features, a shaft and a groove. So the purpose of this demonstration is to show three ways to tie the diameter of the groove, the outside of the groove, to the diameter of the shaft. So I've got three ways I want to demo. I'll talk about the ones I prefer the best, or the one I prefer the best, and then I'll let you decide which one you prefer the best. So I'm going to start off with the one I prefer. So that being said, let me show what I have available here. So under my shaft, that's what the base sketch looks like. And notice I've got three dimensions. Some of these are length and some of these are offset. Then I've got an offset looking like a diameter here. So that's the first one. So the second one, I'm going to stay in this once I get it open. In my groove, I've got this. And notice I've still got some white under constrained geometry. What I'm trying to do is tie that geometry to this limiting element, or what CATIA would refer to as a silhouette edge. So I call this a limiting element, this outside. See, there's no topological feature there. No topological. So when I mean topological, this is a topological edge. The top is a topological face. The cylinder part is a topological face. But there's no topological edge there for me to snap to or do a coincident to. Some CAD systems will allow you to snap to that limiting element or that silhouette edge, but CATIA doesn't like that. So what I'm going to show you first is the use of the silhouette edge tool, or more specifically the project 3D silhouette edge, or even to be more exact, the project 3D canonical silhouette edge tool. So if you go and you find the operation toolbar, you've got corner, chamfer, trim, you've got a mirror tool. The very last one is one of my favorite tools, and that's project 3D element, 3D elements. And so behind it, you will see three other tools. I'm going to drag this to the side. So you've got, as I said, you've got the project 3D elements. You got a tool called intersect 3D elements. You've got a project 3D silhouette edge. And then the last one is the one I want to demonstrate, which is project 3D canonical silhouette edges. What a name, right? So that's CATIA for you. Now the only difference, and I'll show you the difference between these, but there's a minor difference between these two, but they function very, very similar to each other. So what it's going to do is going to project that limiting element, or what CATIA refers to as a silhouette edge. So I want it to project as construction entity. So I'm going to select construction entity, and then I'm going to select the tool, and I'm going to select a cylinder. And what it's going to do is project that limiting element to my sketch plane. It's going to give me a warning. The warning says the operations may be subject to algorithmic instability. You should reconsider your design. And I never have reconsidered my design. I'm sure there's a reason why somebody may not want to do this, but I'll show you two other approaches for solving this problem. But if you look at this, notice it projected as construction because I had construction turned on. Notice if you look at it in 3D, that's what it looks like. Now the only difference, the major difference probably between 3D, project 3D canonical silhouette edges and project 3D silhouette edges is the project 3D silhouette edges will project the top and the bottom as well, which I don't need here. So you can select that too if you wanted to project the top and the bottom. So what I'm getting here now is ability, and I can go coincident to this. So I'm going to just manually add a coincidence there, and now it's tied to that. And so if I make a change to the diameter of this, it's going to update. So that's my preferred method. So notice so my design intent for this is if the diameter of the piston, let's say, updates, then the ring groove needs to update as well. So that's the way I like to do it. Now let me go back and show you the second way. I want to go back to my groove, and I'm going to get rid of this coincidence I just created. I may as well just go ahead and get rid of the silhouette edges. And this method is I'm going to do another coincidence, but I was via snapping to the sketch of the shaft. So I'm going to unhide that, and you can see the sketch of the shaft comes in. Okay. So in order to work this way, I had to make sure I use the same sketch plane, which I did. And of course, I can't, since I'm working in a part body, I can't select something that comes after it in the tree. So in this case, though, I'm selecting something up to the shaft, which comes before it in the tree, which is fine. I mean, that's the order I created this in, so I knew about that in advance. But here, I do have something I can snap to, and it's just the sketch of the shaft. So let me do that with a coincidence. And notice it brought it in as a construction. It looks almost like a silhouette edge now, and then I can toggle that over to be coincident. And there we go, and that works the same way. And so I can hide the sketch. Now if I update this diameter, you can see that it goes with it, which is my design intent. All right, so go back. Now, that was the second way. So the first way was using the Project 3D Canonical Silhouette Edge tool. The second way was doing a coincident to the sketch of the other feature, in this case, a shaft. The third way I'm going to show you how to do. So let me get rid of this coincident, make it back white. So the third way is to put in its own diameter dimension. So if I come in and put in a diameter dimension, so maybe I should talk about creating a diameter dimension if you haven't seen this before, or you need a review on it. So I can create a diameter dimension from the center axis, and this is an axis created in the sketch, to this geometry on the outside. So if you create an offset dimension between geometry and a sketch axis, you can toggle that offset dimension to look like a diameter dimension. Follow me here. So I'm going to go axis, and then I'm going to go geometry. In this case, I'm going to select the white line, which is under constrained. So that's an offset dimension. If I open this up, you can see at the bottom it's created an offset dimension. But since I went to an axis with an offset dimension, I can do a right mouse button, select, and go down and select radius diameter, and it toggles it to display as a diameter. But you see it's still an offset dimension. And if I selected that, it's showing the diameter dimension value, and it's showing it as a diameter. So, but it's still an offset dimension. So if you that is important to understand. If you come back and have to do formulas to it, just keep that in mind. So speaking of formula, by the way, this dimension is not tied to the shaft diameter dimension yet. So right now, these are independent of each other. So if I would have to manually go back in and go, okay, what was the diameter of the shaft? Well, so make it the same diameter, but that doesn't tie the two dimensions together. So what I've got to do is I've got to create a formula between this dimension and the diameter dimension of the shaft. How would I do that? So a couple of different ways to do it. A couple of ways that I would do it. There may be other ways, but a couple of different ways I like to do it is, one is I like to do it straight inside of here. I'm going to select this dimension, or this constraint, if you will. I'm going to go down. And this is, by the way, it's offset 38. So I can select it here as well. And I can go down and I can go edit formula. So go down, offset.38, edit formula. And so what I'm doing is, if you look here, I am having this dimension, which is, if you read it through here, it's part of the part body. It's under the groove.1 feature, and it's under sketch.2, and it's offset 38. And notice the parameter type is a radius. It's displaying as a diameter, but it is a radius. So that is something you need to keep in mind when you're working off of a diameter displayed offset. that it's really a radius behind the scenes. So it's really half the value that you see here. So what I'm going to do is I'm going to make that equal. See the little equal sign out here? I'm going to make this dimension equal to some other dimension. And that other dimension is going to come from the sketch of the shaft. So it's going to go to part body shaft.1, sketch.1, and I can toggle in and actually select it down here, whichever one the offset is. I've got 2 offsets. So I'm just going to go straight to the sketch. Right? It's going to pull up all my dimensions, and there it is right there. Let's see if it shows me. It's not showing me which one it is, but if I select that, notice it populates in here. So it's shaft.1, sketch.1, offset 13. So it's offset 13 here. And notice it's showing as radius 2, which is great because they're both showing as diameters, but behind the scenes they're really radii. So you don't have to do divided by 2 on one of these or multiply by 2. They're both 50.8. In this case it's 50.8. They're going to be the same now. So when I hit OK, notice it makes it the same size. Using a formula, you get this little formula symbol showing that this is being governed by a formula. And if I try to tap off on this dimension and make a change, you notice that it is not allowing me to make a change because of that formula. If you're showing relations on the toolbar, you will see the formula come in here as well. But CATIA straight out of the box, you got to show that. So if I get out of this and I make dimension changes, see, I can make a dimension change there to 200, and that will go with it. So 3 different ways to tie in that neck diameter to the diameter of the groove. I prefer for my class to do the silhouette edges, but I like to show my students all 3 of those methods. So I hope that helps. Have a great day.